Hello everyone, we are Group Block SHK and welcome to our final year project demonstration. Our topic is blockchain-based model for software subscription and license management system. Software has become a crucial component of our daily lives, and various licensing models, such as perpetual, floating, and subscription licenses, have emerged to cater to the diverse needs of software users and vendors. The subscription license model has gained significant traction in recent years, driven by the widespread adoption of cloud computing and software-as-a-service models. Our proposed model aims to address the challenges posed by the used soft case, enhancing the transparency, security, and traceability of software license transfers and management. This model comprises three main components: smart contracts for license models, demonstration software, and a management system that provides an interface for interacting with the blockchain. Blockchain technology is a decentralized digital ledger that reduces the risk of single-point failures and ensures data cannot be tampered with once recorded. OpenZeppelin is a trusted library of smart contracts that provides implementations of popular token standards, such as ERC-721 for non-fungible tokens and ERC-20 for fungible tokens, which facilitate the creation, management, and transfer of tokens on the Ethereum blockchain. The used soft court case established the principle of the exhaustion of rights, which states that the copyright holder's control over the distribution of a product is exhausted after the first sale. It underscores the need for transparency, security, and traceability in software license transfers and management.
Let's look at more about this used soft court case. In 2012, the Court of Justice of the European Union ruled in favor of Used Soft, a German software reseller, in a case against Oracle, a leading software vendor. The court's decision established that the sale of used software licenses is legal within the European Union, even if the software vendor opposes such sales. The ruling reinforced the principle of the exhaustion of rights, which states that the copyright holder's control over the distribution of a product is exhausted after the first sale. This case has major implications for the software industry, highlighting the importance of transparency, security, and traceability in software license transfers and management. As such, it is crucial for organizations to consider this ruling when developing and implementing software licensing models.
The motivation behind developing a blockchain-based solution for software licensing is to provide improved security and transparency compared to traditional licensing systems. It can prevent fraud and unauthorized use while allowing for easy verification and tracking of license ownership. This transparency helps minimize disputes and increase trust among stakeholders. The subscription license model has gained prominence due to its flexibility and cost-effectiveness, which underscores the need for a more efficient and secure solution for managing these licenses. The used soft court case highlighted the importance of enabling secure and transparent license transfers in compliance with legal requirements, which can be achieved through the use of blockchain technology and smart contracts. Lastly, smart contracts can automate different parts of the licensing process, reduce manual work, and minimize human errors.
The limitations of centralized software licensing systems and the potential for blockchain technology to provide users with greater flexibility and control. The popularity of subscription licenses highlights the need for a more efficient and secure licensing management system that incorporates blockchain technology. The used soft court case emphasizes the importance of secure and transparent license transfers. The goal of the research is to create a license management system that uses blockchain and smart contracts to enable tracking, delegation, and sale of licenses and offer users more control over their licenses.
Develop a blockchain-based license management system that integrates with the software license lifecycle. The goal is to create a subscription-based license model that addresses the limitations of centralized licensing systems and provides users with greater control and flexibility in managing their licenses. The research considers the used soft court case and its implications on software license transfers. It aims to incorporate necessary features to ensure secure and compliant transfers within the blockchain-based license management system. The research also involves designing and developing smart contracts for different software licensing models, including perpetual and subscription licenses. The goal is to enable automation and streamline the management of the licensing process. Finally, the research aims to develop a prototype desktop software that uses a blockchain-based license for activation, demonstrating the practical application of the proposed license management system. By achieving these objectives, the research seeks to revolutionize the software licensing industry, providing users with a secure, transparent, and efficient licensing management system.
Now let's go to the demonstration of our project.
First we have the customer user interface here. In here, users can buy licenses for any application. They use software licenses which are initiated for sale. And there are some dummy applications here. You can use this window when you need to update a subscription or cancel a subscription. Next one is the sign message. In the desktop applications, if we use blockchain, there is no integrated wallet in desktop applications. So you need a window to sign a message. Here you can use the MetaMask and sign the message. Then we have activate license. And this is for perpetual licenses. We will show how this works in the next scenario.
This is the software vendor's user interface. In here, software vendor can create license for their details. There are 3 types of licenses, which are perpetual, fixed subscription, auto-renew subscription license. After that you can deploy the license. And you can also see the license you already created.
This is a sample demo application that uses the blockchain. To sign in for this application you need the token ID. And now we look at this procedure. First you have to register. So, you should have the token ID with this address. Then let's go to the customer web application and buy a license for this sample demo application. For this we do the transaction with the MetaMask. Now we get the token ID. Then we should go to the sample demo application and we can register the license with this token ID. Here we got a hash from the application. Now we need to do the activation transaction with this hash in the customer web application.
In here, by entering contract address and token ID, system will check the ownership of our token ID. Now we can paste our hash that generated in the sample application. And then we can sign the hash using the MetaMask. Now we can do the license activation transaction as this workflow. So, now we initiate the activation license transaction. So, transaction has been initiated and let's wait until the transaction is confirmed. We can see the pending transaction here in the MetaMask.
Okay. Now the transaction is confirmed. Now we can sign into the sample demo application. First we need to get a nonce and then enter the token ID. And sign the nonce using the MetaMask to show that we are the owner. Using nonce we can verify it. Now the application backend will check all the details and redirects us to the application. Now other main use case of our system is we allow the users to transfer the license. Let's see the transferring of the license. We have token ID 35, and this is ERC721 compatible. You can import your license for the MetaMask, because MetaMask supports ERC721 token. Now the token is added. Then we try to send this token ID to another user. This should be failed because this is an activated token ID. One of the main cases here is we don't allow the transferring of activated licenses. Let's look at this and send the transaction. Now, the transaction is initiated. Okay, now we can see this transaction has been failed.
Now let's deactivate the license and try again to send the license. Using this we can deactivate the license. As you can see, transaction is confirmed. Now let's try to send this license back to the other user. Now this can't be failed because this license is deactivated now. So, now we can see this is working. This license is transferred to this user.
These are the main use cases of our system. Apart from that, there are subscription-based licenses. The usage of it is quite different. In subscription-based license there are no registration and transaction process. Let's look at a sample application of that. This is an application which uses subscription-based license. Let's go to the customer web application and buy a fixed subscription license token related to this. Okay, we got the token ID 4. Now, let's go to the sample application and try to sign in. In here, there is a no registration process because we don't allow the token means subscription license to transfer. So, there is no need to verify the license is activated or not. Only thing we need to verify is token ID which is relevant to the user. So, we use nonce mechanism for this as before. Now, we can sign into the application using token ID and signed nonce. This should be succeed because we got the token ID which is belong to us. As you can see, if we have the license we can sign into the application. This is pretty much about our demonstration.
The results show that the test cases cover almost the entirety of the smart contracts. However, there are still some branches not covered by the tests. The reason for those not being covered is that they represent second levels of defenses which would only be encountered in extreme situations that cannot be simulated during testing. The high coverage in functions and statements is encouraging, as this means that the essential logic in smart contracts is well tested. It is important to note that achieving high code coverage is an indicator of comprehensive testing, but it is not the sole determinant of the quality or security of the code. Code reviews, security audits, and proper documentation are also critical components of the development lifecycle to ensure the robustness and security of smart contracts.
This is the analysis of the gas consumption during the deployment of smart contracts and execution of their methods. Gas consumption is a critical aspect in the Ethereum network as it is the cost required to perform any action on the network. It is essential to understand how much gas each function consumes in order to optimize the contracts and estimate the cost of interactions. The results are presented in tables below, with average gas usage and its approximate USD price at the time of conducting the tests. Note that the USD prices are indicative and based on a gas price of 30 GWh at the time of testing. The actual prices might vary depending on the current gas prices on the Ethereum network. Future improvements could include integrating additional smart contract models to cater to diverse licensing needs. Enhancing the user interface for ease of use is crucial for wider adoption. This can be achieved by focusing on user experience design and incorporating feedback from users. Conducting extensive testing with larger user bases to ascertain the system's scalability and robustness. Future exploration could involve making the system compatible with other blockchain networks beyond Ethereum to broaden its applicability and address network-specific challenges. That's all of our presentation. Thank you very much.